Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL. Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PL/SQL developer just like you, though I've also written a few books on the PLSQL language. This lesson is part of my series on bulk processing in the Oracle PLSQL language, and the focus of this lesson is getting data faster using bulk collect. Okay, so the agenda for the bulk collect lesson: first of all, a general introduction to bulk collect and how it works. We're going to take a look at unlimited bulk collects and then move on to using the limit clause to constrain the number of rows retrieved by each bulk collect fetch. And then I'll talk about when to convert to bulk collect and when it's okay to leave your queries just the way they are. So, the bulk collect feature, actually a clause added for the into, to qualify the into, is for multi-row querying. So the idea is if you have a piece of code that's retrieving multiple rows of data, and you're currently doing it a single row at a time, then the bulk collect feature allows you to retrieve multiple rows with a single fetch, a single context switch to the SQL engine. You can use bulk collect with any into query or retrieval, so select into an implicit query, fetch into with either a cursor variable or an explicit cursor, and even execute immediate bulk collect into. So I can have a dynamic SQL query and bulk collect into one or more collections. And you deposit the multiple rows of data retrieved into one or more collections. It could be a single collection of records, but if I'm fetching multiple columns of information, then I might have a set of individual collections that I'm retrieving the individual column data into. You just have to make sure that the number of collections, the number and types of the data in the collections matches the data being retrieved in my select list of my query. Here are some good things to know about bulk collect. First of all, if you do a bulk collect select statement, execute select, and no rows are found, Oracle does not raise no data found, which is quite unusual because it seems like Oracle will raise no data found just about any time it can. But in this case, you should think about the select bulk collect as more like a group function execution, select count or select sum. If I execute a group function and I don't find any rows with my where clause, then Oracle does not raise no data found. It either returns 0 for count or null for the other group functions. In this case with bulk collect, what happens is that the collection is returned empty. Second, the into collections, the collections listed after the into keyword, are always filled sequentially from index value 1. That means that there are no gaps, no undefined elements between index value 1 and the index value returned by the count method. So if I retrieve 100 rows of data, then index values 1 through 100 are all filled, guaranteed. That's how bulk collect works. You can only use integer index collections. It's possible with associative arrays to have string indexed arrays, which is covered in a separate series of lessons on collections, but those are not supported for use with bulk collect. And finally, if you're bulk collecting into a nested table or a v-array, then you do not need to initialize or extend those nested tables and v-arrays to make room for your collection data. Instead, Oracle will automatically do this for you, implicitly initialize and implicitly extend the tables and v-arrays to fit the number of rows being retrieved. Otherwise, it would be very, very difficult to work with this feature. So Oracle makes it as easy as possible to do. Now you must be saying to yourself, well, what does it look like? How does it work? Let's take a look at some examples. Now here's a piece of code that with a very small number of lines does some really interesting stuff. First of all, I declare a nested table. That's what this type of collection is. A nested table collection type that has for every one of its elements a row in the employees table. So this one statement is all I need to create a nested table inside my PL/SQL block that mimics the structure of my relational table. I declare a variable based on that type. And then with my single select statement, select bulk collect into, I select all the data from the employees table drop it into my array, my nested table, and again it's filled sequentially from index value 1. Now the Oracle Standard Employees table has 107 rows in it, so now my collection will have 107 rows in it, and then I can iterate through my collection to do whatever processing I was going to do. So for every index between 1 and the count, process the employee. And because bulk collect always fills sequentially from 1, this is the appropriate approach for doing your iterative processing through the collection contents. You don't have to go from first to last. You don't have to worry about any sparse elements, undefined elements between 1 and count. They're always filled. Let's take a look at an example, and then we'll explore in more detail. Here's that same code. I've declared a cursor actually against the employees table. I declared my nested table based on my table. I declare my variable based on my table type. Then I fetch all the rows from the employees table into my variable. And then here's my loop saying go from 1 to the count. Now, in addition to doing that, let's just verify how many rows I've got. So I'm going to display the number of rows or the number of elements in my employees collection. And first of all, let's check in the employees table. I have 107 rows of data. So when I run this code, I should see 107 for this value. And in fact, I do. So again, this one bulk collect operation retrieved all the data from the table because there's no where clause and dropped it into my collection, closed the cursor, it implicitly opens and closes it, and then I can iterate through the contents of my collection and do whatever I was going to do. And as you can see, it requires just a very small amount of code to get this done. And in fact, just to do a little bit of cleanup on my script, I don't need this cursor at all. Let's get rid of it. We don't want any extra code. Okay, so there's a rather simple example of doing bulk collect, and it is in fact a dangerous one. Suppose I write this program today and my employees table has 107 rows in it, and it goes into production and it works just fine. And then over the years after this, I leave the project, other people come on, but this program never changes. And 5 years go by, 10 years go by, and the employees table gets bigger and bigger and bigger. And at some point, we start getting memory errors in the application. And the problem is that I made a very dangerous assumption in this code. I assumed that my PGA, my process global area, the amount of memory I need to run this program will always be sufficient, no matter how big my table gets. But that is a very dangerous assumption, because when my table gets bigger and bigger, the collection gets bigger and bigger, consuming more and more PGA or process global area memory, which is per session memory. And if I have 100 simultaneously connected users, I have 100 copies of the same data, and then I can start getting memory errors. So in general, when you're working with production code, when you're writing these kinds, when you're taking advantage of bulk collect, you want to avoid these kinds of unlimited bulk collect operations because, again, you're making that dangerous assumption that there's always going to be enough memory. And we'll take a look at how you can use the limit clause to constrain the amount of memory that's allocated. But first, let's take a look at the bulk collect test script. Now this is a script that I use to compare the performance, or to get a sense of the kind of improvements in performance I can see with a bulk collect. And you can try this out yourself and just get a sense of the improvement in performance you'll see with the processing of bulk collect, but you can see it right here. The explicit row by row fetching, so I have an open, fetch, close of the contents of my cursor. It took 3.5 seconds. But when I used a bulk collect, notice that my elapsed time took 0.09 seconds. So it went from 3.5 seconds down to 0.09 seconds to fetch 300,000 rows of data. That's an amazing boost in performance. Now you noticed above it that I also had an example of a cursor for loop, and that time was 0.19. I'll come back to this, the cursor for loop being so much faster than the explicit row by row fetch. But what you see here is the potential for enormous improvements in retrieval or query performance using bulk collect. Okay, so it's great stuff, very powerful. Watch out for the unlimited bulk collect approach. What do you do instead? You limit retrieval with the bulk collect limit clause. So if you're certain that your table is never ever going to have a certain number of rows, like it's never going to be more than 100, you could select into a V-array and a V-array collection type enforces a maximum upper limit on the number of rows in that collection, therefore the number of rows that can be retrieved with bulk collect. But that's very unlikely a scenario. And in fact, in general, your tables are growing. You can't put an artificial upper limit on it. And if you're not careful, you could run into the memory errors I talked about. So if you do not know in advance how many rows you might be retrieving, then what you should do is move away from the unlimited bulk collect and instead declare an explicit cursor and then fetch bulk collect with the limit clause. Let's take a look. So here's an example that's more like the kind of code, that you'd want to write in production. I declare an explicit cursor. I open that cursor, and then I have a loop. Inside my loop, I have a fetch statement, and I'm fetching bulk collect into, but I specify a limit clause. What I'm saying here is don't get any more than 1,000 rows at a time. If my table has 10,000 rows that I'm retrieving, then my loop would execute 10 times. If my table has 500 rows, it would fetch just once because it would have gotten all the 500 rows that first time. And then afterwards, I'm going to exit when my collection is empty. So this is an example of using the limit clause to manage the amount of memory used with the bulk collect operation. If I can only afford to allocate enough PGA memory for 1,000 rows, then this is how I can make sure that no more memory than that is ever used. Let's take a look at some details on this limit clause. First of all, the limit clause can be a literal or a variable, and in fact I suggest that you not write code that looks like this. This is a hard-coded value. This is saying I always want my limit clause to be 1,000. But maybe over time you need to reduce that number. Maybe over time you can extend or expand the number, make it bigger, and get some better performance out of it. So rather than hard-coding it, make it a constant, or best of all, make it a parameter that you pass into your program, giving you maximum flexibility. Next, you might ask yourself, or ask me, or ask the experts, what limit should I choose? Now it looks like a limit of 100 is a good default value. You get boosted performance, and you don't use a whole lot of memory. And what I found, and many others have found, including Tom Kite, is that if you set the value for the limit to 500 or 1,000 or several thousand, it doesn't really seem to make that much difference in your performance. You get most of the benefits right out of that first 100 limit. So it might be a good idea to set your default at 100 and then change it if need be. And in fact, you definitely want to keep an eye on it, because I've seen a number of reports from users of this technology where they say that 100 is okay, but when I'm working with really large volumes of data, a larger limit helped me a lot. The best story I ever heard about this feature, both bulk collect and for all, was a woman who came to one of our PLSQL conferences and reported that she had written a program that was taking 2 weeks to run, 2 weeks. And her manager asked her if she could make it run faster, which seems like a really good idea. So she went back and used for all and bulk collect, and she got the performance down to 20 minutes from 2 weeks. Wow. Now that indicates some kind of poor design as well. But putting that aside, it improved performance dramatically. And she said she got the best performance out of a limit clause of 25,000. So feel free to start with 100, but don't hard code it, and be ready to experiment with different limit sizes and see if you can get some additional benefits or boosts of performance by doing so. So first let's take a look at a bulk limit example, and then we'll take a look at some of the nuances of using it. So again, I have my cursor. I don't do a select bulk collect into, which is the first example I showed you, select bulk collect. The implicit query will execute just once and retrieve all the rows specified. So that doesn't give me the flexibility. So I need to switch to an explicit cursor right here. Open my cursor, fetch bulk collect. Here's a limit based on a constant. There's my constant set to 100. And then I exit when there's nothing in my collection. And the way bulk collect works is that with each fetch, it removes all the rows that were in the collection prior to that and then puts new rows into it. If nothing is fetched, then the collection is empty, always empty. Okay. So let's talk about terminating loops containing bulk collect. So now I've got this limit clause, which means I have an open statement, loop, fetch, and end loop. And this is one of those situations where if you follow your habits that you've developed over the years with your cursor loops, then you might run into a big problem. And the habit that we have developed over the years is that we start up our loop, we fetch the next row, and we exit when percent not found. And that makes perfect sense when you're doing row by row fetching. It does not make perfect sense, and in fact is a bad idea when you're working with bulk collect. Why is that? Well, because you might end up skipping some processing of your data. The bottom line, for example, is that if I have 107 rows, well, then I'll fetch 100 rows. I'll process those 100 rows because percent not data is not true. And then I'll go and fetch the next 7 rows, and percent not found will be true, and I'll exit and stop processing before I'm done with all of my data. Let's take a look at a script that will demonstrate that. So the bulk limits stop. So what I've done here is create a table and inserted 4 rows into it, into my stuff table. And then I'm going to take a look at different ways of terminating my loop with bulk collect into. So I open my cursor, which gets all 4 rows. I have a loop, fetch, and my limit clause is set to 3. So I'm never going to fetch all the rows with the first fetch. So I get my 3, and after I do that, I'll see how many rows I fetched, and then I'll exit when percent not found. And if I haven't exited, if I still have stuff in my cursor, then I'll say I'm doing stuff for each row that I fetched. So there's an example of the old habit: fetch, exit when percent not found. And what I'm going to do is compare that to doing a fetch and then exit when count equals 0. So check the collection, not the SQL attribute. And then I'll take a look at doing a fetch and still looking at the percent not found attribute, but moving it to the bottom of my loop body. And then finally, I'll take a look at fetching, doing my processing, and then exiting when my count is less than my limit. In other words, if I was getting 4 at a time or 3 at a time and I only got 2, then I would stop. I run this script, and here's what I see. So exit when percent not found right after fetch. I fetch 3 rows, and I process 1, 2, 3. Then I fetch the 4th row, but notice I don't do anything with it. Contrast that to the count equals 0. I fetch 3 rows and I process all 3 rows. I fetch the last row and I process that row, and then I fetch 0 rows. So what happened with this first approach with percent not found is that my cursor was exhausted with the second fetch. It fetched just 1 row. Let's take a look. So I fetched 3 rows and percent not found is false. I come back up and I fetch the last row. I've got something in my collection, which you saw here, but percent not found is true because my cursor is exhausted. So what can happen is, if you follow the bad habit, is that you will lose or forget to process that last row or set of rows, anything left over from whatever the number, the multiplication by the limit clause is set to. If I check the contents of the collection, I'll always fetch till the very end and process to the very end. If I move percent not found to the bottom of my loop, then I will also do that stuff. I'll process every row and then stop. And the same thing for checking the count less than limit. All these approaches will work for you, except for the one that you're most used to using, which is doing the percent not found right after you fetch. So just don't do that and you'll be fine. So when should you convert to bulk collect? If you're not yet running on Oracle 10, and hopefully all of you are on Oracle 10, but if you're on Oracle 9, then you should be ready to convert every single multiple row fetch that you've got in your code to bulk collect, because Oracle will not automatically do that for you. But the really cool thing is that in Oracle 10.1 and higher, the optimizer now comes with, the compiler now comes with an automatic optimization process. And what it will do is automatically optimize cursor for loops to run at a performance level similar to bulk collect. It's not actually the same thing as bulk collect. It's in C code, but it has the same effect on performance. So the bottom line, well, in fact, let me demonstrate this to you before I go further. We'll take a look at the 10G optimize CFL script. So in my piece of code here, what I'm going to do is compare 3 different ways of querying data. cursor for loop, open fetch close, in other words explicit processing of the data in my cursor, and then my bulk collect statement, get me 100 rows at a time. So depending on the string that I pass in for my approach, it'll run a different approach. And then in my session, what I'm going to do is alter my procedure, set the optimization level to 0, turn it off as if I'm running an Oracle 9, and we'll take a look at the performance of these three statements. Then I'm going to turn optimization on and run it again for each of my three different approaches. And what I'm going to be doing is querying in 100,000 rows from my all-source data dictionary view. So I run my script. This should take, I think, a few seconds to run, not too long. Come on, don't make us wait too long. Now it's running the second block of code, which should be faster because I've turned on optimization. All right, let's take a look. So without optimization, my implicit cursor for loop took about 3 seconds. My explicit open fetch close took a little bit over 3 seconds. My bulk fetch, 1.5 seconds, so the time was cut in half. Then I turned on optimization. Now check out the difference here. My implicit cursor for loop is now running substantially faster than the explicit open fetch close. Not quite as fast as the bulk fetch. I'll come back to that a bit later. But essentially what's happened now is that Oracle has automatically optimized the implicit cursor for loop to run at levels similar to bulk collect. Now you're not seeing an order of magnitude difference here in performance. I'm running on 11.2. If you're running on 10.1 or 10.2, you'll see a bigger difference. This will probably be about 10 seconds compared to 1 second for the bulk fetch. But because the Oracle engine has generally gotten so much faster in 11, the difference between these two has shrunk. But still, using bulk collect, or in this case an implicit cursor for loop, will give you a significant boost in performance. And the point to keep in mind here is that if you're on 10G and higher, you do not have to convert your cursor for loops to bulk collect if they do not contain DML operations and if they seem to be running fast enough. If you have a cursor for loop that has inside of it DML statements, however, and here's an example. Here's a cursor for loop that has within it inserts and updates. In this scenario, you will need to explicitly convert your cursor for loop into a bulk collect, because even though Oracle will automatically optimize this statement, it will not automatically optimize inserts or updates or deletes. Those have to be explicitly converted into for all, which I'm talking about in the next lesson in this series. And the for all statement is driven by a collection, which means you have to fill up the collection with data, and that's what you're going to use the bulk collect for. But if you have a cursor for loop that does not have DML statements, it's read-only, then there's a very good chance that you will not need to convert that to bulk collect. Notice, however, that in general, the explicit bulk collect conversions does seem to run faster. Maybe not a whole lot, 5, 10, 15% faster than the automated cursor for loop optimization. So leave your cursor for loops in place if they're read-only, but if you notice that your program needs to run even faster than it already is running with the implicit optimization, then you might try explicitly converting to bulk collect, and you should see at least a little bit more boost in performance. So, to draw some conclusions. Bulk collect improves performance of queries that retrieve more than one row with each fetch. That's what it's organized to do. The limit clause is critical for production application code with bulk collect to avoid excessive PGA memory consumption. Do not assume that your programs, that your sessions can always support the full retrieval of all the data from the query at once. So instead, create the cursor, create a loop, and for each fetch, specify the limit clause so you manage the memory consumption. Leave it to the optimizer to speed up your read-only cursor for loops. Do not go crazy converting all of your cursor for loops to bulk collect. You might be wasting a lot of your time. It could be fast enough already.